Hello and welcome to the Ukrainian Maths, and before we begin with the logarithms, I believe that some of you might actually be having troubles with understanding the whole thing. Like, when did mathematics begin to be all about? Like, I have this weird log, I have this sub-index A, some number B close to the log, and I have all of these weird formulas, notations, none of which make sense. So to answer you these questions and help you with the issues, I'm going to do some two quick reminders, after which you're going to be thinking that, oh, actually logarithms is no harder than any other function that we have, beginning with powers and roots. To do a quick reminder, what is a power? A power a to n is usually defined as a multi or repeated product of a's, where a is present exactly n times. So say, for example, we have 2 raised to the power of 3. This is going to be a product of 3 2's. So we have 2's, a product of them, where there are 3 of them, which is going to be 4 by 2, which is going to be an 8. Or the other way around, we have 3 raised to the power of 2, which is going to be 3 times 3, which is going to be a 9. And before we move on, let me give you some standard pronunciation, notation, and terminology. So we say a raised to the power of b, a raised to the power of b. There are actually quite some variations, so we can just say a raised to the b. So we do not have to say the whole power of. Or we can just say a to the b. A raised to the power of b, a raised to the b, or a to the b. So moving on, the number a is called the base of a power, which is quite logical because it is located on the base, because we use this b as a sub-index, so the number a is going to be called the base. We call the number b the index of a power, or we call it the exponent of a power, or we can just call it a power. But I would generally not suggest this name, because when we say just a power, we are actually not sure, do I mean the whole power, so the whole result of a raised to the power of b, or do I mean just a power on the top, just the number of the top, just the index? Which is why I would mostly suggest using these two. I would mostly suggest using the index of a power, which is quite a usual variant, or the exponent of a power. To top this off, let's do a couple of more examples so that we are fully sure what the powers are. 5 raised to the power of 2 is going to be a multi or repeated product of 5's, where it's present 2 times. So it's going to be 25, or 5 times 5. Let's take 3 raised to the power of 3. It's not going to be 3 times 3. It's going to be a repeated product of 3 3's. So we have our base number repeated several times, and it is going to be repeated exactly 3 times the index number of times, which is going to be 9 times 3, or just 27. So moving on to the roots. A general idea in mathematics is that we love to do inverses. We like to do inverse operations. So mathematics loves inverse operations, such as, for example, plus and minus, or times and division over. So mathematics love to have one operation and look, okay, what would this operation look like if we were to inverse it? And this is exactly the idea of roots. So to do an example, let's say we have a simple power 4 raised to the 2 equals to 16. So I'm giving you two numbers, the base number 4 and the index 2. Giving you these two numbers, you can get the result 16. So I have a number 4, a number 2, pre-given, and I get the result 16. But now I'm going to inverse the problem. I'm going to do the following. I'm going to say, okay, what would happen if I were to give you these two numbers in advance? And I would ask you about the third number on the bottom, about the base number of a power. So now I ask the following question. Given the result of exponentiation 16 and given the index of a power 2, what is the base of a power? What is the base of this power that we need to get 16 when we square this number? And well, the answer is obvious. We see this one right here. 4 raised to the power of 2 is equal to 16. And the common notation is then the square root of 16 equals to 4. So we are saying that to get the result 16, pre-given the power and pre-given the result 16, we need to take the base 4. Actually, to be fair, here we should have the power of 2 in this square root notation, but it was just said, well, okay, we're going to omit this one. We are not going to use this 2 because we're just going to employ it. But had we have another power here in mind, we would have to put it right there on the top. And to do this as an example, we are going to do the following. Now I'm going to do more examples. Let's say 3 raised to the 2 is equal to 9. So we are going to do more examples. I'm doing the same thing. I am saying that now I have the number 9, so the result of 9, and the index of 2. What would then be the square root of 3? Well, obviously it's going to be just 3, because 3 raised to the second power, oftentimes pronounced as 3 square, equals to 9. The very same way, if I instead say 2 raised to the power of 3, and we know that this is going to be 2 times 2 times 2, so 9. Now I have to do the very same thing. I want to give you in advance two numbers, 8, the result, so my result's 8, and I'm asking, what base should I take that raised to the power of 3 is going to be 8? So now I'm putting this 3 here to indicate I have the pre-given index of 3, the pre-given result 8, and now I'm asking myself what base I should take to get the result 8. And well, obviously, since we are again doing this the other way around, we are seeing the answer in advance, we obviously know that this is going to be just 2, because it is clear here that 2 raised to the 3 is equal to 8. But say I do not give you anything in advance, so I'm doing the same thing, and now I'm writing the third root of 27. So the third root of 27 would be exactly 3. Why? Because we are looking for the base that raised to this third power would give me back the result 27. Now we have to check it. So we say this is true because 3 raised to the power of 3 is equal to 27 again. So everything works just fine. We were asked how to get result 27. We got result 27. And these are exactly roots. They are asking the inverse question. If I have the result and one number in this power notation, what is the third number? So, and the best thing about this all is that logarithm is doing exactly the same thing, which I'm going to do on the next page. So, now we have the very same idea in mind when we want to ask a reverse question, a inverse question. But now we are looking, so we have the same as with the roots, same as with the roots, but now we are asking for the index of a power. So again, when we had our previous example, when we had 4 raised to the power of 2, or 4 squared equals to 16, before we were asking about the base number, and now I'm going to say that, okay, I have the base 4 and the result 16 given. What is the index power, the exponent power on the top, that I should take to get this result 16? And here comes our logarithm notation. We say that the logarithm of 16 to the base 4 equals to 2. And this does not mean anything but what exponent should I take to get 16 when I raise 4 to a certain power. Well, and this certain power is in this case 2, because we see this number 2 on the top. And before I give you some more examples, let me also do some common pronunciation, notation, and terminology. So we write log A, the number on the bottom, the sub-index A, and the number B close to the log, so on the same line as the log. So why do we call it a log? It has some certain Latin roots, but this does not actually make any difference. It's the same as with a sinus function or cosinus function. So is it in the history of mathematics, and we've decided that we are going to call this specific function a logarithm or a log function. But all this means is exactly the question from above. We are looking for the index. So all the logarithm is doing is it's asking you to search for the index or for the exponent. So we pronounce this thing as the logarithm of B to base A. Or we can say the other way around. We can say the logarithm to base A of B. Moving on with some examples so that all of you understand how the logarithm works and what it gives. So say we had, just same as before, several different powers. So say we have 2 raised to the 3 is equal to 8, 3 raised to the 2 is equal to 9, 4 raised to the 3 is equal to 4 times 4 times 4 equals to 16 times 4 equals to 64, and let's say 2 raised to the power of 5 equals to 32, which you can check on your own. So how to rewrite these things with logarithm? We should always remember that the base number and the result are always pre-given, because this is an inverse operation. So we have the result, and for the logarithm we have the base given in advance. So what we are searching for, the powers that are here on the top. So we write this as log base 2 of 8. And what is this exponent that we should have on the top? Well, we have it right here. It's the 3. Or log base 3 of 9. What is the power such that 3 to this power is back 9? Oh, we see the result right there. It's a 2. Doing the same thing, logarithm of 4 to base 4 of 64 is again 3, or the logarithm base 2 of 32 is back 5. Now to do just one example or several examples of what we are doing if we do not have a power written to us in advance. So say we are to count the log of 2 to 16. What is this thing asking us? Well, again, it's asking us for a power. It's searching for the exponent on the top so that we get the result 16 if we raise this 2 to the certain power. So we have this 2, we have the result 16, and we are searching for the power here on the top. And wow, that's a good question. What power should we take in this case? What exponent should we take? And we should take the exponent 4, because 2 times 2 times 2 and another time times 2 is equal to exactly 16. So the log to 16 is equal to 4. And to top this off with one last example, we are having log 4 of 16. So this is almost the same thing, but here, now instead of a 2 here, we have the base 4 here. So we have the base number of a power 4, we have the result 16, and as before, we have to find an exponent here on the top. So what exponent should we take to get the 16? Well, it's 2, because 4 times 4, so 4 squared, is equal to 16. Hopefully you got this all better now. If you are having problems with powers or roots, or check my channel, probably I'm already having a video or a complete series on the topic. So see you in the next video on the logarithm, where we are going to talk about more difficult or about other properties of logarithms, and in a video after that we are finally going to solve some equations with it. Well, see you folks.